Welcome back, PhD listeners. Ready for deep dive number 3?
Absolutely.
This time we're tackling knowledge recalling in large language models.
Fascinating stuff.
You guys sent in 2 seriously dense papers.
Yeah.
Birth of a transformer, a memory viewpoint,
Right.
and cutting off the head ends the conflict, a mechanism for interpreting and mitigating knowledge conflicts in language models.
Wow.
So let's unpack them.
Should be fun.
Basically,
Yeah.
we want to figure out
Uh-huh.
how these LLMs actually pull out facts and information,
Okay.
even when it's not explicitly stated in the text.
Interesting.
So first up, let's jump into Birth of a Transformer.
Okay.
This paper makes a big deal about associative memory
Right.
being key to knowledge recall.
Yeah.
Can you break down what they mean by associative memory?
It's all about making connections.
Okay.
Like, think about it. You see a photo of your grandma. Suddenly you remember those amazing cookies she used to bake? It's that instant link
Right.
between 2 seemingly different things. LLMs do something similar.
Okay.
They create these complex webs of associations between words, concepts, even the positions of words in a sentence.
So it's not just storing info.
No.
It's about building relationships.
Exactly.
Like this giant mind map
a mind map.
with everything interconnected.
Precisely.
The paper digs into the math behind this.
Uh-huh.
They talk about near orthogonality and how information is represented as vectors.
Yeah,
It's all pretty complex.
it is.
But I think I'm starting to get the gist of it
Yeah.
to make things easier.
Yeah.
They use a simplified 2-layer transformer model
Right.
and test it on a synthetic bigogram problem. Can you explain that a bit?
Well, in a bigogram problem,
Uh-huh.
the model has to predict the probability of a word occurring given the previous word.
Okay.
Like artificial, followed by intelligence.
Got it.
By focusing on this simply model, we can really see those associations forming.
So it's kind of like a peek behind the curtain.
Exactly.
You're seeing the gears turning.
That's a great way to put it.
This is where things start to get really cool.
Oh.
The paper talks about training the model on specific trigger output pairs.
Uh-huh.
And this leads to the emergence of what they call an induction head.
Interesting.
It sounds like the model is going beyond simple memorization
You got it.
and actually learning to infer or reason based on its existing knowledge.
It's moving towards real understanding.
Okay.
Think of it like this.
Mhm.
The induction head leverages those learned associations
Yeah.
to make predictions,
Okay.
even when the info isn't explicitly there.
So it's like
Thus-
filling in the blanks.
Absolutely.
Yeah. Okay, so let's say I'm the LLM
Okay.
and I've read tons of stuff about scientists and their discoveries.
Mm-hmm.
Then I come across a text,
Yeah.
mentions Marie Curie,
Right.
but doesn't specifically say she discovered radium. Would the induction head help me make that connection
Bingo.
based on my memory of her work?
Exactly.
Yeah.
It's a crucial step
Oh.
towards sophisticated knowledge recall.
The paper really digs into how this induction head develops during training,
It does.
analyzing gradient dynamics
Uh-huh.
and the roles of different transformer components.
Yeah,
Seems pretty crucial
absolutely.
for understanding how knowledge recall actually works.
At its core,
Right.
they're essentially pinpointing the parts of the model's brain
Okay.
responsible for making those connections.
And retrieving the right info at the right time.
Exactly.
Fascinating stuff.
It is.
LLMs are clearly more than just pattern matchers.
Way more.
They're developing complex memories and even mechanisms that resemble human reasoning.
It's pretty mind-blowing.
Okay.
Yeah.
Let's switch gears to the second paper.
Okay.
Cutting off the head ends the conflict.
Right.
This one deals with a big challenge. What happens when an LLM's internal knowledge clashes with new information?
Yeah, that's a tough one.
Like,
Yeah.
imagine the LLM has learned
Huh.
Paris is the capital of France
Right.
from its training data.
Okay.
But then we give it new text
Yeah.
that says Rome is the capital.
Oh, no.
Now the model has to decide what to believe.
Yikes.
Its own memory
Yeah.
versus new input.
A real dilemma.
Exactly.
And this is where those memory heads and context heads come in.
Okay.
They're like 2 voices
Mhm.
in the LLM's decision-making.
I see.
One arguing for what it knows.
Yeah.
The other pushing for the new stuff.
Even if it's wrong.
Right.
So it's a battle between
And it is
internal and external knowledge.
And that battle
Yeah.
plays out in the later layers of the transformer,
Okay.
especially during attribute extraction. Imagine asking the LLM,
Uh-huh.
what's the capital of France?
Okay.
While also giving it that text about Rome. Now it has to figure out which source to trust.
That's tricky.
It is.
The LLM's in a tough spot. It
Definitely
needs to
neat.
weigh the evidence,
Uh-huh.
make a judgment call.
Yeah.
So this paper suggests
Yeah.
the key is in those later layers,
Right.
how those attention heads integrate all the information.
It all comes down to that.
It's like a final showdown,
Climax.
determining whether the LLM sides with its internal knowledge
Uh-huh.
or the potentially conflicting external context.
A crucial point in the process.
So how do we help these LLMs resolve these conflicts effectively?
But that's the million-dollar question.
Choose the right info consistently.
Right.
Cutting off the head introduces this idea of pruning head via path patching, PH3,
Yeah.
a very targeted approach
Very targeted.
to dealing with these knowledge clashes.
Instead of retraining the whole model,
Huh?
which can be a huge pain,
Yeah.
PH3 identifies and prunes specific attention heads, the ones causing the conflict.
It's like a surgical strike.
Precisely.
Removing the problematic part.
While leaving the rest intact.
So we're essentially fine-tuning the decision-making process,
You could say that.
making it more reliable.
Much more reliable.
This PH3 technique seems like a game changer
It has the potential.
for ensuring the accuracy of LLMs,
Absolutely.
especially in those critical applications
Yeah.
where getting it right is crucial.
Absolutely crucial.
This has been incredibly insightful so far.
It has.
From the inner workings of associative memory
Uh-huh.
to the complexities of resolving conflicting info,
Yeah.
all within this fascinating world of knowledge recall.
It's a wild ride.
But we've only scratched the surface.
There's always more to uncover. Picking up on Birth of a Transformer again,
Yeah.
I thought their discussion of near orthogonality in embeddings was super interesting.
You know, I gotta admit,
Mm-hmm.
that part kind of made my head spin a little.
It can be a bit much.
Can we break that down? It's like
Yeah.
for someone who's still wrapping their brain around all the technical stuff.
Of course. Remember we talked about vectors,
Right.
representing words and concepts
Yeah.
in a high-dimensional space.
Okay.
Near orthogonality means these vectors are mostly perpendicular.
Hmm.
Like,
Yeah.
imagine a really organized filing system,
Okay.
each file in its own spot.
Right.
No overlap.
Got it.
This helps the model keep its memories distinct.
So it doesn't get confused.
Exactly. Prevents mix-ups when retrieving information.
Makes sense.
And the paper shows this beautifully
Oh.
with their simplified model and that bigger gram problem.
Right.
By keeping those embeddings near orthogonal,
Uh-huh.
the model can tell different word pairs apart.
And make accurate predictions.
Precisely.
This whole idea of associative memory,
Yeah.
it seems relevant to other LLM stuff too.
Oh, absolutely.
Not just recalling facts.
Right.
I'm thinking like question answering,
Mhm.
text summarization.
Yeah. Even creative writing.
All about making connections.
Right. Like,
Right.
you need to connect and retrieve info in a way that makes sense.
It's fundamental.
It's kind of like the difference
Right.
between memorizing a list of ingredients
Uh,
and actually understanding a recipe.
perfect analogy.
LLMs are going beyond surface patterns.
They are.
Grasping the meaning
It's amazing.
makes you think differently about these LLMs.
It does.
They're not just mimicking,
Nope.
they're showing signs of genuine understanding.
Which is both exciting and kind of scary.
I know, right? It's mind-boggling.
These papers are really challenging our assumptions.
Yeah.
We're seeing these glimpses
Yeah.
of real cognitive complexity.
Blurring the line
I think
between artificial and human thought.
Fascinating stuff.
So, cutting off the head,
Yeah.
they use that example,
Uh-huh.
asking about the capital of France,
Right.
then giving the LLM conflicting info.
Remember.
They pointed out those 3 stages of processing:
Okay.
enriching semantic information,
Uh-huh.
propagating question information,
Okay.
and finally extracting attribute information.
Right.
And that's where the conflict happens,
Oh.
in that final stage.
Attribute extraction.
Exactly. All that info swirling around,
Yep.
internal knowledge, external context.
Yeah.
The model has to decide.
Which one to trust?
Precisely.
Their analysis of attention patterns is interesting.
It is.
They basically knocked out parts of the input
Right.
to see how it affected the prediction.
Clever approach.
What did they find?
Well, Blocking attention to certain parts
Uh-huh.
of the conflicting info actually helped.
Helped.
Yeah. The model was better able to recall the correct attribute from memory.
So it's like
Hmm.
helping the LLM focus
Exactly.
by dimming the lights on the distractions.
Love that analogy.
So it can hone in on the good stuff.
The most reliable source.
And PH3 builds on that
It does.
by pruning those conflicting attention heads.
Like a guide,
Yeah.
helping the LLM navigate that messy world of conflicting info.
And it does this without retraining the whole model.
Right. Much more efficient.
This is huge for making LLMs more reliable.
Absolutely. Especially in critical applications.
I'm curious, though,
Yeah.
about the long-term implications of techniques like this.
Okay.
Are we shaping how LLMs think,
That's
controlling their decisions?
it's something to consider.
It's powerful stuff.
It's
But it raises ethical questions, too.
definitely. We need to be mindful.
Okay.
Yeah.
Let's go back to Birth of a Transformer for a sec.
Sure.
They get into the nitty-gritty
Uh-huh.
of how associative memory works.
Right.
Specifically with superpositions of embeddings.
This is where it gets really interesting.
Right. Remember we
Yeah.
talked about vectors
Mhm.
representing information?
Okay.
Superpositions are about combining those vectors.
Like blending colors
Okay.
to create a new shade.
Got it.
The model can represent more complex ideas.
By combining simpler ones.
Exactly.
So it's not just individual words anymore.
It is richer than that.
The model's representing these
The
relationships.
connections between things.
The paper gives that example.
Oh, yeah.
The initial representation of a token.
Uh-huh.
It's a sum
Okay.
of the token embedding and its positional embedding.
Meaning and location.
Right. The model's considering both.
It's getting a more nuanced understanding.
It's like,
Yeah.
it's not just what the word means,
Uh-huh.
but where it is in the sentence.
Exactly.
And as the model processes info
yeah.
through those multiple layers,
Right.
the representations get even more complex.
With the residual connection.
Right. It's like
Yeah.
each layer adds more detail,
Building up that tapestry of meaning.
connecting everything
When
together.
words, concepts, positions.
A cohesive whole.
Beautiful, isn't it?
But Birth of a Transformer
Yeah.
points out some limitations too,
Oh.
with this linear approach
Right.
to associative memory.
What do they say?
Well, linearity makes things simpler,
Okay.
but it can also be a constraint.
How so?
Like
Yeah.
simply adding two embeddings together
Uh-huh.
might not be enough
Okay.
to represent a new concept
All right.
that emerges from their interaction.
It's like trying to describe
Yeah.
the taste of a complex dish
Okay.
by just listing the ingredients.
You miss the overall flavor.
Exactly. You need something more.
To capture that emergent meaning
Right.
that goes beyond some of the parts.
The paper suggests exploring other techniques,
Like,
compressed sensing, MLPs with nonlinear activations,
it's interesting.
things that can handle those more complex relationships.
It's amazing how they're pushing the boundaries
They are.
of associative memory.
Finding new ways to represent knowledge.
And remember, Birth of a Transformer focuses on a simple model.
Just 2 layers.
Imagine the complexity
I know, right?
in models with hundreds of layers.
It's mind-blowing.
Okay,
Yeah.
let's revisit the training process for a minute.
Sure.
How that induction head emerges.
Okay.
The paper emphasizes training on those
Huh.
trigger output pairs,
Right.
and they did these cool experiments,
Oh, yeah.
freezing different parts of the model
During training.
to see how it affected development.
Fascinating stuff.
What did they find?
Well, they found that freezing certain components,
Okay.
like the key query matrices and the attention mechanism,
Mm.
it completely stopped the model.
Stopped it.
Yeah, from developing any meaningful associative memory.
So those components are crucial.
Absolutely crucial.
Oh, the whole thing to work.
Like essential gears.
Right.
Without them, the system breaks down.
It's not just about the overall architecture.
No.
It's about the specific roles
Right.
of each little part.
The interplay between them.
They also dug into gradient dynamics, how the model adjusts its knowledge during training,
The heart of learning.
and their analysis shows how those different components,
Okay.
the matrices, keys, queries,
Uh-huh.
they all shape those dynamics.
Like an orchestra.
Yeah.
Each section contributing to the harmony.
We can trace how info flows
Right.
through the model.
And see how it leads to that induction head.
It's like reverse engineering the brain.
It is.
to understand learning and memory.
And this is just a simple model.
Right.
Imagine the complexity in larger ones.
It's incredible what they're doing.
Pushing the boundary.
Of our understanding of AI.
Absolutely.
Oh.
Yeah.
One more thing from Birth of a Transformer.
Okay.
That caught my eye.
What's that?
They observed that with those superpositions of embeddings,
Right.
the learned memories often focused on a single embedding.
Interesting.
And treated the rest as noise.
So they're prioritizing information.
Yeah. Like having a whole toolbox.
Okay.
But only needing a hammer.
Perfect analogy.
For that specific task.
The model selectively attends to the relevant info.
It's filtering out the rest.
Background noise.
It's like the cocktail party effect.
Exactly.
Focusing on one conversation.
Amidst all the chaos.
Our brains do that too.
We do.
Prioritizing what's important.
It's a fundamental principle.
Of information processing.
Across systems.
Biological and artificial.
It's amazing.
This opens up so many possibilities.
It does.
For collaboration, neuroscience, and AI.
Oh, absolutely.
By studying LLMs.
Uh-huh.
We might understand our own brains better.
It's like a window into our own cognition.
Unlocking secrets.
That have been hidden for so long.
And it goes both ways.
Funny.
We can learn from LLMs.
Yeah.
But we can also use what we know.
About our own brains.
To inspire new AI.
That's the beauty of it.
It's a two-way street.
Exactly. A feedback loop.
Different fields. Enriching each other.
Working together.
To understand intelligence.
In all its forms.
It's a pretty amazing time to be in this field.
It is. So much to discover.
It's wild to think.
I know.
These LLMs are building their own mental models.
Right.
Complete with associations, memories, even ways to deal with conflicting info.
It's like they're developing their own worldviews based on the data they've been trained on.
It's a testament to deep learning.
It really is.
And the researchers who build these models
are pioneers.
Pushing the boundaries of what's possible.
Absolutely. We're seeing systems that learn from experience, process info in complex ways.
And do things we thought only humans could do.
It's changing everything.
And you know, the deeper we go into these models, the more we learn
about
not just about AI, but about ourselves too.
Our own minds.
Exactly. It's like holding up a mirror
to our own cognition
and seeing things in a new light.
Those parallels between LLMs and humans, how we learn and remember.
And it's fascinating. Like,
remember in Birth of a Transformer, how the model focuses on relevant embeddings? Treats the rest as noise. Just like we do.
Yeah, it's like the cocktail party effect.
Exactly. Tuning out the distractions.
Focusing on what matters.
Our brains have evolved to do that.
And now we're seeing it in LLMs too.
It suggests there are these fundamental principles
of information processing
that apply across systems.
Biological and artificial.
It's mind-blowing. This opens up so many possibilities.
For collaboration.
Right.
Between neuroscientists and AI researchers.
Work together.
To unlock the secrets.
Of the mind.
Exactly.
It's like having this new tool.
A new lens.
To study our own cognition.
Maybe even discover things.
That we've never known before.
And it goes both ways too.
Meaning?
What we learn about the brain. Can inspire new AI.
Like in neuro-inspired AI.
Right. Taking cues from nature.
To build better algorithms.
It's a beautiful thing.
It is.
This exchange of ideas.
Between fields.
Enriching each other.
Leading to new breakthroughs.
And as we build these LLMs, more powerful, more complex, the ethical side becomes crucial.
Absolutely.
We got to make sure these systems align with our values.
Right. And that we use them responsibly.
For the benefit of society.
Ethics and progress.
Hand in hand.
Always.
This is just the beginning.
Of a long journey.
Full of exciting discoveries.
But challenges.
But if we work together.
Collaborate. Share ideas.
And keep those ethical considerations front and center.
We can harness the power of AI.
For good.
For a better future.
Well, PhD listeners. That's a wrap.
On.
Our deep dive into knowledge recalling.
It's been a fascinating one.
But the conversation continues.
Right. Keep exploring.
Dig into those papers.
Ask those tough questions.
And see where this all leads.
That's an exciting time.
In our next episode, we'll be tackling in-context identification.
Interesting.
Exploring how LLMs identify and extract
the right info
within a given context.
Can't wait.
Until then, keep those research gears turning.